Thank you for joining our presentation on the Wolf Creek Master Drainage Plan, which we prepared for Arapahoe County. My name is Craig Hoover, and I lead the Water Resources team at Bohannon Houston and served as the principal in charge on this project. Rivka Wine was the drainage lead, and Madeline Olivius did the hydrology and hydraulic analysis on the project. Our main point of contacts with the county were Kathy Valencia and Ryan Seacrest. The county's primary project goal was to proactively develop a master drainage plan, or MDP, for Wolf Creek and its tributaries to serve as a guide for stormwater management as the area develops. The county selected Bohannon Houston through a competitive request for proposals process. Bohannon Houston, having decades of master drainage planning experience and having recently completed the Kiowa Creek MDP, which is the watershed adjacent to Wolf Creek, was a logical choice for the county to prepare the Wolf Creek MDP. The tasks we completed as part of the project included obtaining topographic mapping, obtaining field survey of existing drainage crossings, completing baseline hydrologic analysis, analyzing existing infrastructure capacity, delineating inundation extents to inform development, developing recommendations for improvements, including an alternatives analysis, and then lastly, creating the Wolf Creek MDP document itself. So where is Wolf Creek? Located in eastern Arapahoe County, the Wolf Creek watershed is directly east of the Kiowa Creek watershed and is south of Bennett and southwest of Strasburg, Colorado. At this point, I'm going to turn it over to Rivka, who will tell us a little bit more about the unique issues that had to be overcome as part of the project.
The Wolf Creek watershed is a rural agricultural watershed, which lends itself to opportunities for adaptive management. As part of this project, our team developed creative solutions to meet the county's needs for drainage improvements. Due to the rural nature of the watershed, the team was able to tailor analysis to meet the needs of the county. For the Wolf Creek MDP, less detailed analysis was needed for tributaries, resulting in substantial cost savings. Rather than using the county's definition of tributaries having drainage areas of 130 acres or more, a tributary was defined as having drainage areas of 1 square mile or more. The tributaries that were analyzed on this project are shown in blue on this figure. The county does not have the equipment to maintain ponds or the right-of-way required to construct stream stabilization projects. So recommendations focused on the roadway crossings and identification of areas where stream stability is of concern. The light blue circles on this figure indicate areas where there has been lateral migration based on review of historic imagery. The pink lines indicate areas where banks are steeper, and there is the potential for future slope instability. Since most of the creek and its tributaries cross private property, the capital improvements were focused on roadway crossings. By monitoring development and managing drainageway improvements with an adaptive management approach, the county can use funds effectively and in a cost-efficient manner, as opposed to more costly alternatives such as expensive grade control structures. A quantitative alternative evaluation matrix was completed with input from the county on the weighting of the various criteria and on the scoring of each alternative component with respect to the criteria. As part of this project, our team used RASMapper to edit the HEC-RAS models and inundation limits more efficiently. This expedited the hydraulic modeling and review, saving time and effort as direct benefits to the county. And now I will turn it over to Madeline to talk more about the hydraulic modeling and how we used RASMapper to streamline the hydraulic model development and review.
Thank you, Rivka. I wanted to give some brief background on the hydrology, even though it was pretty straightforward for this project. Just wanted to cover some of that information. We used the standard Colorado urban hydrograph procedure to analyze the basins for the 83 square mile Wolf Creek watershed with more detailed analysis, smaller subbasins for the 37 square miles within Arapahoe County. The area is primarily agricultural and undeveloped with some low density development in the downstream end closer to Strasburg, but mostly farmland and made the hydrology pretty straightforward. We used parcels from the county, zoning, aerial imagery, classified the land uses, inputted the parameters to CUHP, and then routed the hydrology using EPA's SWIM model. The resulting peak hydrographs, I just wanted to show kind of an example of the hydrology outputs. In this case, we analyzed the 2-year, 5-year, 10-year, 25-year, 50-year, 100-year, and 500-year return periods for the watershed. So this is an example of what the peak discharge profiles look like along the main stem of Wolf Creek from the county line at the downstream end of Arapahoe County all the way through the county to the upstream end of the county line. We looked at Arapahoe County's planning documents and utilized the projected percent imperviousness for the different areas of planned development within the county to look at future developed conditions, as well as the Arapahoe County 2035 transportation plan to look at planned road improvements to make sure that we were including analysis points for any planned future crossings of the roads. So then after we had all the hydrology completed, we used those peak discharges to start our hydraulic modeling. So within Arapahoe County, the entire step of Wolf Creek and 8 major tributaries were modeled using HEC-RAS. The tributaries were defined as having a contributing drainage area of greater than 1 square miles. How we made those delineations in conjunction with the county to meet their goals for the project. We ended up using a combination of 1D and 2D HEC-RAS, as was mentioned before. The 2D was required for this area because of circumstances of having such wide and flat floodplains where there was a lot of sinuous and braiding flow paths throughout the study area, as well as most of the crossing structures being undersized for the larger events, the 100-year and the 500-year that were modeled, which led to multi-directional flow that was at the crossing structures overtopping the roads. We still also did use 1D HEC-RAS for analysis of the tributaries where peak flow rates were smaller and didn't cause as many issues with the multi-directional flow. Structures were more adequately sized, and then we aligned that 1D and 2D analysis at the downstream end of the 1D models to most effectively use those 2 different approaches for areas that required them. Within Wolf Creek, the study area, Wolf Creek itself had 17 miles of river that was analyzed in our HEC-RAS model and 21 miles of tributaries we looked at in 10 crossing structures, 7 of which were undersized for events that we included in our analysis. For an example of what some of these complex areas looked like, we had, in this case, this is a view of the terrain along one of the tributaries of Wolf Creek and then Wolf Creek main flow path through the study area. So from the terrain here and these inundation extents that are shown in these figures, you can see how flow is combining and overtopping the road and diverging, and there's some unique topographical features out here that would have been pretty complex to try to capture the flow in these different areas with 1D cross sections. Here's another example of flow. This was along one of the tributaries at the upstream end where there's no existing crossing structures, culverts underneath this road, and flow was crossing the road at multiple locations, which whenever we tried to initially analyze using 1D, we realized was going to be complex. So it's kind of these situations when we first looked at the modeling led us to using a combined 1D, 2D approach. And one of the tools that really simplified and expedited the process for doing that was using the RASMapper tools that have come a long way even since we did this project. We did this project using HEC-RAS 5.0.7, but HEC-RAS 6.0 is out now, which has even better capabilities than we had whenever we started this. But some of the key parts and tools of RASMapper that really expedited the process for this project was using the tools in RASMapper and the GIS capabilities to set up the model to begin with. So we started with using the drainage flow lines from the hydrology, imported them as a shapefile into RASMapper as the start for our center lines for setting up the cross sections. The terrain viewing in RASMapper, which we were looking at before, is really user-friendly with a lot of display options and drawing contours on the fly. So it's a lot faster than trying to review contours and draw cross-sections and tweak cross-sections in GIS, as we had previously done before using HEC-GeoRAS. The automatically resampling of the terrain and recalculating the parameters. So if you move a cross-section just a little bit in RASMapper or adjust the orientation, there's tools in there that will resample the terrain to calculate the cross-section parameters, recalculate the reach lengths and the base stations and all the things that you need for a 1D cross-section once you have the initial setup, which was very helpful in our case. After we had initially run the model with 1D cross-sections throughout, the results viewing in RASMapper made it apparent that we were going to have some issues, as from just viewing the initial 1D results, there was diverging flow paths and split flow, and we were going to need to do a lot of cross-section additions and tweaking of the alignment to try to capture the flows in the areas. And so that became really apparent with reviewing the results in plan view and seeing the cross sections at the same time. It really makes it intuitive and easy to interpret your results and see where there are going to be issues. Similarly, with viewing the terrain, it's easy to identify areas of ineffective flow, areas where the cross sections aren't containing the flow, and where additional cross sections are needed. So those kind of situations were really easy to identify using the RASMapper tools of the results in conjunction with the cross-sections. The GIS interface capabilities of RASMapper are excellent, having the ability to export and import shapefiles for viewing, which really made it possible for us to do combined 1D, 2D models. We have separate models, separate HEC-RAS projects for the 1D cross sections and separate projects for the 2D areas, but being able to export the shapefiles for the inundation and combine them in GIS and smooth and adjust as needed led us to being able to have a complete product really easily, as well as being able to export the raster data of depths and velocities for more detailed viewing and producing the figures for the report for the county. Really helped us deliver on what we were expecting. The other helpful tools in RASMapper that we utilized was terrain modifications. So for example, there are 2 bridges in the study area that could not be simulated as culverts in HEC-RAS 5.0.7. When we did this project, there was not the options for adding bridges to the model, culverts only. So primarily the structures in the study area were culverts or bridges that were shaped similarly enough, box shapes with straight abutments, that we could simulate them with culverts. But there was a couple conditions. This one in particular, this is 6th Street Bridge, that there's a center pier, as you can see, and then spill through abutments on the side. And this structure could not be well, we did not choose to simulate it with a culvert internal structure to the model. This structure was not anticipated to experience pressure flow in the model, so we did not need to account for the deck. So we used the terrain modifications and merging options in HEC-RAS. So I created just a 1D model separate from this with cross sections at the upstream and downstream faces of the bridge, modified the terrain to include the pier, and then generated a HEC-RAS terrain from that model, which then could be merged with our LiDAR surface to capture the spill-through abutments and the wall pier in the middle for this area, which worked fine for our purposes of not needing to account for pressure flow under the bridge. So now I'd like to open the model and kind of walk through some of the interesting features and view some of the results interactively. So this is the entire study area from the Arapahoe County line on the southern end, and these rivers flow from south to north to the Arapahoe County line on this north end. So from this view, These green cross-sections are the 1D cross-sections within the study area along the various tributaries that we were able to analyze using the 1D models and the first segment of the Wolf Creek main stem. And then these areas showing the inundation limits are the 2D modeling areas that we used. We had 3 of them where there was complex flow overtopping the road, where we wanted more detailed analysis of some of the diverging flow paths. So this first section along the first tributary, and this is the third tributary, and then from all of Wolf Creek, including some minor tributaries from here all the way until the downstream end. So these results that we're seeing now are the maximum depth for the 100-year event. In this case, I wanted to look at the there's an option in here for reviewing particle tracing, which kind of shows you the direction of which flow is taking within your inundation extents. So in this case, you can see how flow is definitely multi-directional flowing along. There's some significant ditches along the roads in these areas, but is deep enough to be overtopping the road in many cases in this area. This analysis allowed us to more closely determine what kind of alternatives would make a difference in this area, and in the long run, expedited our model development process rather than trying to capture these various flow paths in this two-dimensional flow area. The extents of our model, this is where the upstream 1 square mile of contributing area started for this tributary. So there was model inflows along these 2 locations. And then we tied it into the 1D cross sections down in this region, where you can see from the aerial imagery flow is more channelized and becomes more one-dimensional. So this cross section would be the downstream boundary of the 2D model and the upstream boundary condition of the 1D model, and allowed us to tie results in together like that. The next area that I wanted to look at was down here, where we can see this is from the same screenshot in the presentation earlier, where model results are definitely two-dimensional. You can see from this tributary, there's an inflow coming from this direction, and the tributary in the main stem of Wolf Creek, this flow is coming down along the main stem, and how the timing of the peaks as well as the two-dimensional flow, sheet flow over the land, and the sinuosity of the channel in this area was much better captured by the 2D model than it would have taken us much more effort and time to analyze in a 1D setting. So this view of kind of what's going on here helped us, and the inundation extents for this area were more easily determined than from a 1D model. An area that was a primary concern for the county once we had initial model results was where this is more further developed to the north. This is I-70 crossing, and the county line is at the road here. And so this is where the more already densely developed and where future development is most likely to occur. And there is minimal crossing structures in this area. This is 6th Street, where that bridge that we looked at with the spill-through abutments is, where we had to modify the terrain to analyze that flows. And then along this road, where there's tributaries coming in from the west in multiple areas, there are undersized and minimal crossing structures, one down here, and some minimal CMCs in this area. So the inundation in this area was really shallow sheet flow that was crossing the road and spreading out over all of these houses around in these houses in this area, as well as along the main stem. And later in the events, overtopping even the main channel extents from its capacity and affecting the land along this east side as well. So being able to analyze these 3 different inflows and look at how their combined effects were affecting the land in this area helped us to come up with solutions for the alternatives that were recommended as a final for this report. And there was various alternatives that included adding a low water crossing along the road in here, as well as upsized structures at the south end and improving the ditch along the west side of the road so that flow could be further directed away from these houses and along roadside ditches until it reaches the main stem at this bridge that had adequate capacity to pass those flows. So overall, these 2D areas were a much faster model development process for the complex flow issues that we had in this region, and using RASMapper gave us interactive tools and results and output to meet the project development goals, as well as analyze alternatives more effectively and efficiently for the project. Thank you.
Thank you, Madeline. That was an excellent review of some of the challenges that we faced and some of the innovative ways we used RASMapper on the project. So, relying on experience completing previous MDPs, Arapahoe County and the BHI team have streamlined the process and details for completing these types of studies. The Wolf Creek MDP will help the county get ahead of development in this area and guide improvements to the drainage systems within the county. The recommendations are realistic and feasible. Using the MDP as a planning tool will help plan for the future development and improvements in a unique way by starting with data and a plan for drainage infrastructure. Deliverables featured technical data with lookup table capabilities and cross-referencing to other files for easy data refreshing at the push of a button, making the report adaptable as changes occur over time. Thank you for attending our presentation on the Wolf Creek MDP. And with that, we'll open it up for any questions you may have. Thank you again.